We're going to work through number 13, number 14, and number 15 on your worksheet that you were working in class today. I hope that will help you understand those problems, and so we'll look at some others and hopefully understand them from there. So I'm just going to do them on a different slide, but we're going to work on those three problems. So number 13 is asking you to find this. This stands for the second derivative, or y double prime if you want to call it y double prime. So basically what I'm trying to figure out is I'm going to find the derivative, and then I'm going to find the derivative again on that problem. So we have 1 minus xy equals x minus y. So I'm starting by finding the derivative. Alright, the derivative of 1 is 0. Then I'm going to do the product rule here. Be careful with this negative. The negative goes to both parts of the product rule. So I have first times the derivative of the second, plus, except I'm going to carry through that negative, the second times the derivative of the first, which is 1, equals the derivative of x is 1, the derivative of y is y prime. So I've just been finding the derivative, nothing crazy here. I do want to get my y primes together, and I want to move everything else on one side. Factor out your y prime, and then divide. So we have that y prime equals 1 plus y over negative x plus 1. Now, we're trying to find the second derivative. So I've got to find the derivative of that again. I'm going to do that on a different slide. We have that y prime was 1 plus y over negative x plus 1. Alright, so we're trying to find the second derivative. That means I'm going to have to do the quotient rule, because I'm trying to find the derivative of that. So I have the bottom times the derivative of the top. Alright, the derivative of 1 is 0. The derivative of y, I still use my y prime. And then minus the top times the derivative of the bottom over the bottom squared. So it's kind of strange that there's a y prime in there, but what that means is that where y prime is, I'm going to put what y prime is. So to make it all x's and y's, I'm just going to put y prime in to where it tells me it is. I'm almost finished. Because I'm multiplying this, I can go ahead and reduce that. So on top I have 1 plus y, multiply here. It's negative 1, and then the negative in front's another plus 1. Negative y, and then another y is a plus y. And then reduce, so 2 plus 2y over negative x plus 1. And I forgot to square this when I was doing the quotient rule, so it is squared. And there's our final answer. The only really hard part here is knowing that when you take the second derivative, that you have to use the first derivative in the second derivative, and you had to plug it in right there. Alright, number 14. So number 14 is asking us to find the equation of the tangent and the normal lines. Well, in order for us to find the tangent and the normal lines, I have to find the slope, which means I need to find the derivative. Alright, so let's just go ahead and find the derivative. 3x squared plus 3y squared y prime, and then find the product rule first times the derivative of the second, plus second times the derivative of first, which is 2, so I'm just going to put it in front of the y. Bring everything with y prime on the same side, and everything else goes to the other side. Factor out your y prime. Divide by y prime. Alright. Alright, so it's asking me to find the tangent line and the normal line at 1, 1. So I first need to plug in the 1, 1 and then figure out what the slope is. So when I plug in the 1, 1, I get 2 minus 3 over 3 minus 2. So that's negative 1, which is m. Alright, so the tangent line. I already know that m is negative 1, and I'm using the point 1, 1. So I do y equals mx plus b, solve, add 1 to both sides. So y equals negative x plus 2. For the normal line, I know that if the slope of the tangent is negative 1, then the slope of the normal is 1. I still use the point 1, 1. Y equals mx plus b. That's going to be b is 0, so y equals 1x plus 0, or y equals x. So tangent normal line is really not any different, just that you have to consider what the points are. Now, on this problem, it is possible that they would have said, here's the equation, and they might have said, find the tangent at x equals 1. Well, in order for me to do that, I would have to know the y value, because the equation of the derivative has a y in it. So what you would do is you would plug 1 in for x, and then you would move everything over and try to solve it. Now this one doesn't come out very nicely. I'd probably have to solve that on the calculator to figure out what y is, but on problems where they gave you that, usually it's more simple for you to figure out y, but that's sort of how you go about if you had to figure out what y was if they didn't give you the full point. Alright, number 15. So this problem is asking us to find the horizontal, the points where the horizontal and vertical tangent lines are located. And in order for me to do that, I'm going to have to find the derivative. Remember, the horizontal tangent line is where the derivative is 0. The vertical tangent line is where the derivative is undefined. So let's just start by finding the derivative. I'm forgetting my y prime right there. I think you know how to do that. Let's go ahead and get the y primes together and everything else over on the other side. Factor out that y prime. Could factor out a 2 if I wanted to, but it's not going to matter. So here's my derivative. So let's start off with finding where the horizontal tangent lines are located. The horizontal tangent line is where the slope equals 0. Well, this is the slope, and the slope would equal 0 where the derivative equals 0. Well, if I cross multiply, then I get that negative 2x plus 4 equals 0. So horizontal tangent lines are where the top is equal to 0, because that's the only way that it could equal 0. So solve it for whatever you get. Sometimes it's x, sometimes it's y. So there's a horizontal tangent line at x equals 2. Well, I'm not finished because I need to know the y value. So I plug this x equals 2 into the original equation, the x squared plus 4y squared minus 4x plus 16y plus 4 equals 0, because that's the original like xy equation. And I'm going to plug the 2 in for x there. So I'm going to have 2 squared. 2 times 4 is 8. All right, let's see what we have. 4y squared plus 16y, and then 4 minus 8 plus 4, that's all 0. Factor out of 4y. And solve, and so I get y is 0 and y is negative 4. So that means there's horizontal tangent lines at 2, 0 and at 2, negative 4. Right? Vertical tangent lines are where the slope is undefined. The slope would be undefined wherever the bottom equals 0. So I take the bottom of the equation I got, set that equal to 0, and solve for y. Subtract 16, divide by 8, I get y is negative 2. Then I do the same thing as I just did on the last problem. My original equation was x squared plus 4y squared minus 4x plus 16y plus 4 equals 0. I'm going to plug in negative 2 for y. Negative 2 squared is 4. 4 times 4 is 16. Negative 2 times 16 is negative 32. So I get x squared minus 4x. That's negative 16 plus 4, which is negative 12. I'm trying to find the factors of 12. That multiply to give me 12. That add to give me 4. That must be 6 and 2. You won't always have two answers, but I do on these two problems. So I get x is 6 and y is negative 2, and then x is negative 2 and y is negative 2. So both of those places are places where there would be vertical tangent lines. I want to do one more problem to show you one more type of example. This example is on page 31. It's page 154, number 31 in your book. You don't have to look it up, but just in case you want to know where it's come from. It gives you an equation, and one part of the problem wants to know the derivative. So we'll do that first because that's, in order to finish it, that's what we would do. So 3x squared plus 3y squared y prime. Do the product rule here first, times the derivative of the second. Don't forget your y prime. Plus, but I got that minus the second times the derivative of the first equals 0. Let's go ahead and we'll switch that around just a little bit just because it's easier. Take the negative 3x squared over and the y squared over. Factor out the y prime. And then divide. That was like the A part. The B part asks about horizontal tangent lines, and the C part asks about vertical tangent lines. So I want to go ahead and do the C part. This was A. So I know that vertical tangent lines are where the bottom is equal to 0. So here's the bottom. And I need to solve that for 0. Notice there's an x and a y in there, so I'm just going to factor out a y so I can solve for whatever I get. And that helps me because now I know that y is 0, and I also know that 3y minus 2x equals 0. So I'm just going to solve for y here. I'm just going to add 2x and divide by 3, so I get y is 2x over 3. Now, this one's pretty helpful because once you realize one of the equations or one of the places where you have vertical tangent lines, to get the x, you plug that back in the original equation. So just remember our original equation was x cubed plus y cubed minus xy squared equals 5. So if I plug a 0 in for y, I get x cubed equals 5. Take the cube root on both sides, so x is the cube root of 5, which means one place of a vertical tangent line would be the cube root of 5, 0. Now we got to deal with this y equals 2x over 3. Sometimes you might not have a number right there. If you don't have a number, what that means is you're going to just plug in that whole thing into the original equation. So the original equation was x cubed plus y cubed minus xy squared equals 5. And what we got was that y equals 2/3 x. So I'm going to plug that in the place of y. Okay, and then I'm going to solve. So I'm going to cube the 2 and the 3. And then here I'm going to square everything. Square the 2, square the 3. X squared times x is x cubed equals 5. So then I'm going to just take the 1 plus 8 over 27 minus 4 over 9. I'll put that in the calculator because hopefully nothing like that would have to be without a calculator. And I get 23 over 27 x to the third equals 5. So then I'm going to divide by that. 5 divided by 23 over 27. I get 125 over 23. And then I'm going to take the cube root of that. If I want to leave it like that, that's okay. Or if I raise it to the 1/3 power of the cube root, you get 1.803. Make sure you've got it to 3 decimal places. Now, I have the x. In order to get y, I have to come back up here and plug that into that equation that I had. So I would multiply that by 2/3 to get the y. And I get 1.202. So this x and this y give me the place of where there would be a vertical tangent. And it's the same process, it's just that you might not have a number to start with. You might have an equation that you have to plug in for x and for y. So here's your try problems. On the first problem, there's the equation, and I want you to find the tangent and the normal line at the point 43. On number 2, there's your equation, and I want you to figure out where the places where it would have a horizontal and a vertical tangent. I will tell you that when you originally set something equal to 0, you'll get a number for x and for y for each one of those. But when you go back to get x and y on the second part, you're going to get decimals. And you might have to just like graph the equation that you have when you set it equal to 0 to find those decimals. So they're kind of strange. Just wanted to let you know on that last one.